This question says, prove that 1 plus tan squared theta is equal to secant squared theta. State any restrictions on the variable. Now you'll notice here I have tan and secant. Those are trig ratios, which suggests to me that I can go back to the first principles definition of any angle in terms of x, y, and the length of the terminal arm, r. And so if I have a terminal arm, the terminal arm always is measured from the positive x-axis. It has a length of r, and the coordinates at the end of that terminal arm are x and y. And so if those are x and y, that means that the x coordinate is represented by the horizontal distance on that triangle, and the y coordinate is represented by the vertical distance on that triangle. Now, that we're going to label as theta. And what we can do here is we can say, well, tan, we know that tan is going to be the opposite over the adjacent. And so because tan is opposite over adjacent, part of SOHCAHTOA, that means that tan of the angle is going to be equal to y over x. So that's the first thing to keep in mind. Secant, though, this is a reciprocal identity. So secant is the same thing as 1 over cos. And SOHCAHTOA tells us that cosine is equal to the adjacent over the hypotenuse. And the adjacent side is x and the hypotenuse is r. So cosine of an angle is x over r. Now if secant is the reciprocal of that, that means that secant of an angle has to be r over x. So these are the definitions that we need now to do this proof with. So let's go ahead and do that. Whenever we do a proof, we go left side and we separate it from the right side. So we're going to go 1 plus tan squared theta. And the right side is equal to secant squared theta. And so this becomes 1 plus, well, tan we said is y over x. So this is going to be y over x all squared. The secant we said was r over x. So this is going to be r over x all squared. And now what we can do is we can expand and simplify both sides of this. So I'm going to get 1 plus y squared over x squared. Now, I have one term on the other side. So how do I get this to be one term? Well, if I can write this with a common denominator, that can be one term. So I'm going to write this by multiplying the top and bottom by x squared. Whatever you do to the top, you have to do to the bottom to keep the fraction the same. And what this is going to give me is going to give me x squared over x squared plus y squared over x squared. So this becomes, because it has a common denominator, x squared plus y squared over x squared. Now let's go back to the right side here for a moment, because if expanding this out, we get r squared over x squared. So those have the same denominator. So the only difference is the numerator. Well, look at the right triangle that we drew over here. That is, using the Pythagorean theorem, x squared plus y squared equals r squared. So this, by the definition of the Pythagorean theorem, becomes r squared over x squared. And therefore, the left side is equal to the right side. Now, the last thing this question said to do was state any restrictions on the variable. So in order to state restrictions on the variable, what we want to do is we want to look at the variables that we have here and say, are any of those ever not allowed to be 0? Well, if you go through this, we can see that we can't ever have x be 0 all these places. X can never be 0. We can't divide by 0. And so because of that, that means that x cannot be 0. And then what we do is we take that and we put it in terms of angles. Well, when is x 0? If I turn this angle all the way up to here, now the x coordinate becomes 0. And if I continue to turn it all the way down to here, the x coordinate is 0 again. Those angles are at 90 and 270 degrees. And so what we would say is that theta cannot be 90 or 270. So this identity works except for when theta is 90 and 270. For more on trig identities, check out the video on the left. The playlist on the right is videos of the entire trig unit in grade 11 functions. Thanks so much for watching, and I hope that was helpful.